Afternoon all, it's Postbag and it's a Banggood special. This big bag has come from Banggood from China and it contains home tools and electronic DIY kit. Actually, I've just noticed that this is from Germany. Never heard of Germany. So let's rip it open. Oh, there's also something else shoved down the side. Let's check that out. So this first item is an IP camera. It's branded ESCAM. It's H.264 compression. It's got infrared LEDs and it's IP66, which means that it's waterproof, so it can be used outside. This is the UK power adapter. The box does look a little bit bashed up. Let's have a quick look at the power adapter. Probably nothing very special. Well, it is at least UK, legal UK, because it's got these wide diameter rings. This has to be 9.5 millimeters, if I remember rightly. And we've got a 12 volt DC, 1 amp output power block with a little green LED. Now there is something rattling around inside of here, so we'll find out what that is in a moment, I guess, but let's have a look inside. Okay, instructions. Oh, a CD. Now, I'm not sure if my PC can take a little mini CD because it's one of those sort of slide-in front-loading ones, but my old laptop can probably take that, so that's fine. And here's the camera. It's known as the ESCAM brick, and it's got a built-in mounting bracket there, which we can use to attach it to a wall. These are the infrared illuminators, and of course that's the lens. And on the back it has a Wi-Fi antenna connector. Still got something rattling around inside there though. So I've connected the IP camera to my router via this Ethernet cable, and the power brick 12 volts is going in there, and we know the default IP address because it's written on the box. So that's here. It's 192.168.1.128. The user name is admin and the password is admin. These are all default settings. I can change those. Now I've covered up the UIP P2P, a peer-to-peer, I think they are, settings, because they're unique to this camera. And it's not that I'm concerned about anything in particular, I'm just not sure what the implications of those details are just as yet. So I've covered those up. But let's have a look at 192.168.1.128 on my browser. Well, it has responded on this IP address. My home network uses the third quartet octet. No, third octet is a 1, so the third octet matches. So I can talk to this camera without any changes to settings. But it's saying the site uses a plugin, application XRT player, that is unsupported. Now I've got a feeling this uses ActiveX, and so it's unsupported in Chrome. Let's try it in Internet Explorer. So in Internet Explorer, I've got this box come up. Now it said username admin, password admin. So let's type that in and see what we get. Oh, we get a live image. And I can show you it's live by putting my hand in front of the camera. So now I've put the camera on the windowsill. You can see the camera up here looking out of the window. It can see the hedge outside. And we're getting this rather nice image here, high resolution image. There's no movement really, but that's only because there's nothing going on outside. This is a live image. If I bring the camera over to the other side, you can see a panel here of controls. These are pan and tilt controls. It's not a pan and tilt camera, so they're not doing anything. There's a live clock here. What's that? 26th of November. 23:36. Well, it's certainly not 11:30 at night, so that might be set to China time possibly. And we've got a load of controls here, although they are a little bit sort of covered up by the image. Now I've noticed that if I, instead of saying fit size, say source size, then the source image becomes much smaller, and of course now it's not blocking over these controls here. Interesting. Now if I click on media, we've got a panel comes up here. I'll get in a little bit closer, I think. And here we've got lots and lots of menu items: video, audio, image, OSD, that's on-screen display, and pan, tilt and zoom. Now we've got the mainstream set to 1920 by 1080. Clearly we're not seeing that because that resolution would be my entire monitor. There is a substream where the resolution is 640 by 360, and that's clearly what we're seeing if I click home. And in fact we can see down here in this box it says we're looking at the substream. So that's interesting. Now I wanted to play with the bit rate. The bit rate for the substream is currently set to 768. So what if I set it really low, 128, and apply that? What would be the implications of that on the video? And what I'm expecting is high resolution but very slow update rate. So if I stick my hand in front of the camera, or actually just wave the camera left and right, you can see how blocky it goes because it's having to send all those changes through the video, and I've given it a very small bandwidth with which to do it. Given enough time, of course, that comes back to the high resolution image. In fact, let's go back to media and change the resolution of the substream to something higher. We've got 704 by 576, is it? And that requires a reboot. Okay, so I've clicked apply. It says IP camera is rebooting. Please don't turn off the camera. So I'll just let that finish. So now it's gone a bit sort of squished because that's not the size of a UK plug. So I don't quite know why the aspect ratio has gone funny. But what I wanted to play with is this. This date and time is part of the video stream. So because I've now got a high resolution image coming through a very narrow bandwidth pipe, if I produce lots of movement in the image, it's got a heck of a job to send all these updates. And you can see that there are massive artifacts now around that clock. And then if I leave it to sort of transmit all of the updates, it eventually gets this very nice high resolution. But of course there's very little change in the image because nothing's actually moving. I find that fascinating. Right, now here's a picture of me because I've put the camera down on the desk. So let's see where I've put it. And I've put it here, and the reason I've done that is because I want to get the infrared illuminators to come on. So let's shut the blinds so it gets really dark in here. Oops, something fell over. Still hasn't put the illuminators on. Ah, there they go. The infrared illuminators. Now you can hear a click as well. And I can see that the image on my screen is going from colour to black and white. So I think what's happening, oh, it's so dark in here now, the illuminators are staying on. Let's have a look at the computer monitor. Yes, so this is the image with the infrared illuminators on. And I think what that click is a filter, the infrared cut filter being moved away from the lens. Just see if I can get some light into the camera. Yes, I've put some light into the camera. The filter has pulled away. The lens takes a lot of time to respond to the removal of that filter, but that will eventually come up. It is very, very slow. There it comes. Now, the illuminators just came on again. So we're back to black and white. Well, this is all fascinating stuff. I'm going to have a lot of fun playing with this camera. So on Banggood.com, this is the ESCAM Brick QD900 Wi-Fi, 1080p, P2P, peer-to-peer, cloud IP, infrared waterproof security camera, $49.99. I'm not quite sure what's happened to the image. There are lots of images of the software, but no image of the actual camera itself there. You've got to choose the adapter for your country here. And I do still need to resolve the mystery of the rattly thing inside the camera, so there will be a teardown. So next we have this, and I really like this, but at the same time I kind of hate it. This is going to be very, very interesting. Let's open it up. So this is a pair of build-it-yourself walkie-talkies. Now these are not sophisticated walkie-talkies. These are extremely primitive, but they take me back to my childhood because when I was about 13, I think, I was given some money by my mum and she said, bring back anything you don't spend. And I spent it all on a pair of walkie-talkies. Because back then, walkie-talkies were rare. I think they might even have been illegal at the time, but I managed to find some. Now here we have the circuit layout and also the circuit diagram. I'll come back to that in a moment. Here's the pack of bits. Here's the circuit board. Interesting shape, isn't it? Now on the back of the case we've got the 9-volt battery compartment. Horrible 9 volts, but at the same time I love it. And inside we've got the speaker. Now there's no microphone because the way this works is that when you press the transmit switch, which is a switch that I think it's there, it pushes in from the side, it rewires the entire circuit, not only to make the transmitter a receiver, if you push the button in, of course it turns a receiver into a transmitter, but it also turns the speaker into a microphone. And these speakers make really lousy microphones. So I'm really hoping that the audio quality on this is shockingly bad. So here's the circuit diagram. Now it's a 49.8 megahertz circuit, but it's all discrete. It's absolutely gorgeous. Look at it. All these discrete transistors. Now there's the switch, which effectively rewires the entire circuit to go from a transmitter to a receiver. There's no sort of frequency lock components like a crystal, so how stable this 49 megahertz will be, I don't know. Probably have to tune it by adjusting the core of this inductor up here, the inductor that's linked to the antenna components. It's lovely, isn't it? It's just gorgeous. Now what else have we got? We've got basically a spring in a piece of tubing. That's quite interesting. That's just literally a spring in a bit of tubing. So that's the antenna, is my guess. A couple of stickers to stick on the front of this walkie-talkie to make it look a bit more walkie-talkie-ish. Yeah, they go there and there. That's going to look great. And now, here are all the components. So transistors, resistors, capacitors. There's the switch. So it's a spring-loaded sort of changeover switch. Press to talk. That's excellent. Now, where's the inductor? Yep, here it is. It's a little, well, I don't know, 6 or 7 turn, looks like hand wound inductor. It has a ferrite core in it with a little bit of rubber band stuck in there just to provide a bit of friction for the ferrite. So yes, this will be manually tuned. Going to have to make sure that when I stick my screwdriver in there I don't break the ferrite, because that used to happen a lot, I seem to remember. Manually tuned 49 megahertz. Fantastic. So I'm really looking forward to building this, what's that, volume knob? This 49 megs walkie-talkie set with all discrete components. It's just going to be so nostalgic. So much retro. Oh, it's just, I love it. Just love it. So here on Banggood.com we have the 2 pieces DIY electronic intercom kit, walkie-talkie interphone learning kit, or nostalgia kit as it's going to be for me. I mean, it's really cheap, isn't it? $8.17 for the 2 parts. When I bought mine when I was 13 years old, it was 30 quid as I remember it for a pair of walkie-talkies. Just going to be such excellent fun. Okay, next up we have this, and you can probably tell what it is. It's a component tester. Let's take it out of its bag. Yep, big LCD. I think it's 128 by 64. A little ZIF socket, zero insertion force, where the component goes in there. Single button to test. Little pad for surface mount components. And also the 1, 2 and 3 connectors come out on a little connector here. Don't seem to get a cable for that, but you could use that to put little probe clips on to test odd components that won't fit in either of these two locations. Okay, let's power this up. So I've hooked up a 9-volt battery, and there it goes, 8.8 volts. Testing, no part inserted, so let's insert a part. What have I got lying around? I've got a couple of MOSFETs. So this is an IRF-Z44N, and this is a IRF-3205. Okay, let's put this one in. So let's put that in. Switch on the tester and see what it makes of that. Yep, it's telling me it's a N-channel enhancement mode MOSFET. Pins 1, 2 and 3 are gate, drain, source. We've got an input or a gate capacitance of 708 picofarads and a forward voltage of 639 millivolts. Now that's the forward voltage of the body diode. It's actually shown the parasitic body diode. It's a diode which is a function of the component. Can I switch it off and back on again? Yes, I can. And so my guess is that the 643 millivolts is the forward voltage of that. We've also got a threshold voltage, VT, 3.9 volts, where this thing starts, I presume, the very beginnings of switching on, but that's not going to be the voltage at which this is on with its lowest on resistance. Well, I wouldn't have thought. Now look at that, 708 picofarads for the RF Z44N. I know that the IRF-3205 has a much lower on resistance and therefore will probably have a higher gate capacitance. Yes, 5 nanofarads gate capacitance rather than the less than 1 nanofarad of this one. So again, N-channel enhancement mode MOSFET, gate drain source. We've got a forward voltage of the body diode of 575 millivolts this time. Okay, I've just picked one of the transistors out of the walkie-talkie kit, so let's poke that in. Oh, that's going to need its legs brought out a little bit. Put that into pins 1, 2, 3. Close it down, and let's see what we've got. We've got a PNP transistor, emitter-based collector, gain of 324, forward voltage, presumably of the base emitter junction, of 674 millivolts, current collector emitter, some funny symbol of 0 milliamps, current collector emitter with an S, I don't know what these are actually, again of 0 milliamps it looks like. Nice little symbol of a PNP transistor there. Collector emitter base on pins, well, 3, 1 and 2. Yeah, that's excellent. Now I've got another one of these. I'm going to put them side by side. So this red one is one I bought a while ago on eBay. Let's press test on both of them, see what we get. That one's not working, probably because the battery is flat. Okay, let's try again. This is the one that says fish, something Taobao. And that one's come up with the MOSFET. So they both got the MOSFET, they are different types. But this one from Banggood does seem to have more information. It has the forward voltage of the body diode. Let's get that back. This doesn't seem to have that. It has the threshold voltage, 3.7, and the gate capacitance. This one has that forward voltage as well. Let's see what it does with transistors. Right, so now both of them have a 2N3904 in them. Get that off and back on again. Let's see what they say. Yes, okay, so the Banggood one gives you the addition of writing little C, B and E letters as well as the numbers on the symbol. Also gives you these ICE things, which I don't actually know what are. Forward voltage is on both. NPN BJT. This Banggood one doesn't actually say BJT, but I suppose that's pretty obvious, isn't it? Good. So here it is on Banggood.com. This is the GM328A transistor tester graphic wave signal. Yes, that's true. This can output signal waves, I believe. It's also an LCRRLCPWM. What is all that? Meter inductance. It's $15.20. Let's just have a look at see if we can get these output signals. Yes, if you press and hold, you get a selection menu of transistor, frequency, F generator, function generator is that? 10-bit PWM, C plus ESR, equivalent series resistance at TP1 and 3, rotary encoder, self-test, contrast control, show data, and switch off. So there's a lot more in here besides just the component tester. I can't go through it all now because I'm running out of time, but interesting. And lastly, we have this, and it is a giant boost converter. We've got an enormous inductor there, and you can see that it's triple wound. So there are in fact 3 parallel windings, just really to give it the current capability, because this is a 1200 watt boost converter. Now if we look at the input side, I'll turn it around this way so that it's more logically laid out. On the input side we have 2 car style blade fuses plugged into sort of soldered on sockets. There is place on the PCB for 3 of these, and it does say on the PCB, I have to get in closer in a minute, 10 amps I think, but these are in parallel, 220 amps, that's 40 amps on the input. Yes, this is what I was looking for, this T30 amps. So it looks like you could have 3 10 amp fuses in parallel. They've chosen to populate this with 2 20 amp fuses, giving a 40 amp input point at which the fuses blow. Just interested to know what I can do with this on the output. Now let's have a look at some other bits. Here is RV1 V adjust. You can just about see it says there. This is I adjust, or is that A adjust? Yeah. So this is the current limit adjust. This is the voltage output adjust. There's a chip here. It's been ground, so I can't see whether it's a off-the-shelf converter chip, SMPS chip, or whether it's a microcontroller. Now this has a link, and it says here you link it pins 1 to 2 for 20 to 60 volts, pins 2 to 3 for 10 to 20 volts on the input side. So if I'm going to put 12 volts in as an input, I'd choose the 10 to 20. If I'm going to put a higher voltage in, and I did think I might try connecting that big solar panel I've just got to this, I'd have to link it for 20 to 60 volts. That panel can put out up to about 40 volts, so it'll be interesting to see what happened there. Now another application of this, of course, will be driving LEDs, 100 watt LEDs. I've got 2 here in parallel, which I recently used this boost converter to try and drive. What I really want is to drive as many of these 100 watt LEDs in parallel as I can. This boost converter successfully drove 2. This also has V and I adjustments. I'll put a link up to a video where I was playing with that. Here of course is our old friend, the 600 watt, or so-called 600 watt boost converter. I particularly like it because it's got a 2.1mm input jack. I've modified mine to put up one of these little voltmeters on there just so I could see what the output voltage is. But this boost converter is 1200 watts if you put the appropriate voltage in on the input. Now, much like the 600 watt boost converter, which has its own heatsink attached, this one also has a heatsink attached. It's slightly lower profile, silver aluminium. There are 4 components here, 2 on this side, 2 on this side. I'm assuming, because I can't see any large diodes, that 2 of these are MOSFETs and 2 of them are diodes, although I can't be absolutely certain about that. It looks like there's some high current work going on the board underneath there. And of course the rest is all capacitors. So, high power LEDs or something to do with solar power. Not quite sure yet where this thing will end up. So on Banggood.com, this is the 1200 watt 20 amps. Now that must mean 20 amps on the output because the input is fused for up to 40 amps. DC converter, boost, step-up power supply module. In is 8 volts to 60 volts. Out is 12 volts to 83 volts. This is $17.99. And yes, in the spec below that, 20 amps is the limit of the constant current range. So 0.3 amps, 300 milliamps, to 20 amps looks like it's the range of the constant current potentiometer. That's what it looks like. And so that's it. This little bundle of goodies is today's Postbag. Cheerio.